Hello and welcome to YourPedia. My name is Aman Sharma and I am your mentor for CSE at YourPedia. So today we'll be doing a question from our NPTEL question bank series. The question is from Theory of Computation and the topic name is Push Down Automata. Question number 59. You can find the question on page number 102. Now the question is, consider a push down automata which runs on input alphabets ABC. So the input alphabets will be A, B, C, and the stack symbols which we are using in this is Z0 and X. So Z0 and X will be pushed and popped out of the system, and Z0 is the bottom of the stack symbol. Whenever the stack will be empty, Z0 will be the last element present in the stack. Whenever you reach Z0, you can say that the stack is empty. It is the bottom of the stack symbol. Now initially Z0 is in the stack. The set of states of PDA is S, T, U, F. So there are 4 states, S, T, U, F. S is the starting state and F is the final state, and the PDA accepts by final state. So whenever you reach the final state, the language will be, or the string will be accepted. So what it is telling us is that let's say that if you have inputted a string and you are at U state, then the string will not be accepted. But if you input a string and you reach final state, then the string will be accepted by the PDA, or you can say the string that belongs to that language which corresponds to this PDA will be accepted. Now the transitions of given PDA below are depicted in a standard manner. For example, now what are the transitions here? For example, the transition SBX, S, B, X to TXZ, Z0, means that if you are at state S and the symbol on top of the stack is X, then, and the input is B, let's say that input is B, you will move to the state T, and when you move to the state B, then it can read B from the input and move to the state T after popping the top of the stack element X. So the X here will be popped and Z0 X will be pushed into the stack in that order. So Z0 X will be pushed into the stack after popping X. So this is the basic transition function given. Now you have been given multiple transition functions, and by using these transition functions we will try to make the PDA, and then we will try to solve what language will be accepted by this PDA. So let's see the transition function. So first is, when S is there and input symbol is A and top of the stack element is Z0, you will remain at state S and you will push 2x into the state. Z0 will remain there. So at S, for each A, for an A you will push 2x into the stack. After that, now this is a accepting transition function, because when you are at S and there is the string that you are inputting in the PDA is epsilon, or you can say the null epsilon string, and the top of the stack symbol is Z0, you will not push anything and you will straightly go to the final state and it will be accepted. So what you are saying here is that epsilon will be the part of the language. So A0, B0, C0, these type of strings will also be accepted by our PDA because these are nothing but epsilon. After that, at S, when you are at S and the input symbol is A and the top of the stack element is X. Now after Z0, when the input was A, you pushed 2x into the stack. So for obviously top of the stack element will be X. So when top of the stack element is X, input is A and you are at S. So you will remain at S and again you will push 2A into the stack. So for each A, you will push 2 X's into the stack. So no matter how many A comes, let's say that 3A comes, then 6X will be pushed into the stack. After that, when you are at S and let's say a B comes and the top of the stack element is obviously X, you will move to state T and X will be popped. So for B, X will be popped and you will move from state S to T. Now at T, whenever you are at T and the number and any B comes, you will remain at T. So this means that there will be a self loop. So how many B comes, no matter how many B comes, For each B you will pop an X. So for each B you will pop X. After that, this is not a transition function that is given in our table. After that, when you are at T and C comes, now whenever you are at T and C comes, you will move and the top of the stack element is X. You will move to U, the state U. So from T you will go to U, and for C, X will be popped. After that, when you are at U, you will remain at U for the input C and top of the stack element X, and X will be popped every time a C comes at the state U. So for each C you will pop X and you will remain at state U. Now when the string ends, let's say that all of the A's, B's and C's have been completed and the string has ended, then at U, when the string ends, the last element will be epsilon, and the top of the stack element, if is Z0, you will move to the final state and accept it. So let's try to make the PDA for this. So these are the states S, T, U and F, which is the final state also. And initially, if the string is epsilon, you will directly move to the final state. Let's say that epsilon Z0, and it will remain, or you can pop the Z0 and reach the final state. Now, as far as our transitions go, we will try to take stack symbols and input for these. Let's say an A comes and the stack symbol is Z0. Now if we are at state S and input is A and top of the stack symbol is Z0, we will do what? We will push 2x into the state. So let's say for A, top of the stack symbol is Z0, then 2x will be pushed into the stack. After that, let's say that 2a's come after that. Now for the second A, the command is, if the top of the stack element is X, you will push 2x into the stack. Now for the third A, again 2x will be pushed into the stack. Now let's say a B comes. Now when a B comes, the state will change from S to U. So whenever a B comes and top of the stack element is X, it will be popped and state will be changed to U. So for the first V, X will be popped out of the stack. And whenever, now after this, whenever a B comes, you will remain at T and the top of the stack elements is if X, then you will pop that X again. So let's say again a B comes, you will pop this X. After that, let's say a C comes. Now whenever a C comes, you will move to the next state U, and if the top of the stack symbol is X, you will pop it. For the C, you will pop C. And here again, whenever a C comes, you will keep on popping the X, and when the string ends and epsilon Z0, again epsilon. Now let's say that string ends here. Now epsilon is the input symbol, but top of the stack symbol is X, so there is no move for this, so you will not be able to move forward, and if you are not able to move forward, you will not reach the state F, so this string will not be accepted. Now let's say again a C comes. Now for C, again you will push the X. Now let's say that string ends. Again top of the stack symbol is not Z0, so you don't have any forward move. For the third C, again C will be popped, X will be popped. For the fourth C, again X will be popped. Now when the string ends, if a string ends, epsilon will be the input symbol, Z0 is the top of the stack element, and you will reach F and the string will be accepted. So the string that will be accepted by this PDA will look like this: AAA BB 4C. Now how can you make the language which will be accepted by this PDA? Now you can see for each A you are pushing the twice the number of X's in this. So let's say that the string will look like AL, BM and CN. Now for each A you are pushing 6x into the stack, 2x into the stack. For 3 A's you will push 6x. So for each B you will pop 1x, and for each C you will pop 1x. So you can say that our stack will be empty only when these will be able to pop all the X in the stack. So these should be obviously should be equal to 6. So then they 6x pushed, 6x popped. So sum of these should be equal to the x's pushed by this. Now these what we are doing in our question is we are pushing twice the number of a's. So if number of a's are L, so the number of x that are being pushed into the stack is 2L, because you are pushing twice the number of x, and for each B and each C you are popping 1x. So if the number of x's pushed into the stack is 2L, then you need equal amount of B's and C's to make the stack empty. So in this what we are doing is, if the language is AL, B raised to power M, C raised to power M, N, then 2L should be equal to M, M plus N, twice the number of A's should be equal to the total number of B's and total number of C's. So if you want to see which of our option is correct, then the correct option should be option number C in this, A raised to power L, B raised to power M, C raised to power N, and such that 2L should be equal to M plus N. So I hope you understood the concept of push down automata and the concept of transition functions. So keep watching for more interesting questions like this. Keep preparing, and thank you.